In this first video, we will show the software frequency switch we have come up with within the NetFPGA platform. The frequency switch between 125 MHz and 62.5 MHz and vice versa. That is changed automatically through a governor which currently checks the overall bitrate in the input queues. The scenario we've chosen is the following. So here we have a packet generator software which sends packet at different bit rates to the NetFPGA router with the software frequency switch capability. In particular, the one I'm pointing now with the cam is another NetFPGA host where the packet generator is run as a different NetFPGA project, and we will refer to this machine as the packet generator. This is actually the NetFPGA with the software switch capability, where you can see the NetFPGA card, which is exactly this one, and which is placed on top of the PCI Smart Extender PCI X64UB, which is exactly this one. And it has two voltage lines, one at 5 volt and another one at 3.5 volt. These two lines are connected to the oscilloscope, where we will see the power consumption measurements. Note that the 3.5 line in the NetFPGA corresponds to the power consumption of the FPGA circuitry, whereas the 5 voltage line corresponds to the Ethernet port's power consumption. So this is our router, and in the router, this is the screen of the router, and we will show this graphical user interface where we can notice our queues, where we have the received packets, and the packets, once we receive the packets, they are forwarded back to the power generator. Packet generator now is going to send 3 million packets of 140 bytes in each of the 4 ports of our router at 200 megabytes per second. And here is the user interface, the graphical user interface of our router, which shows here the 4 ports where we are receiving the packets, and actually here in the input queues, and here the 4 queues corresponding to the 4 Ethernet ports where the packets are going to be sent back to the traffic generator. We now see that, let's just focus on one of, like port 1, packet sent, approximately at time 25,000, so it's 25 seconds, we finish receiving and sending the packets. And as we have used as bit rate the 200 megabytes per second per port, the frequency clock was set to 62.5 megahertz. And here in our oscilloscope we can see the current power consumption. The number on top, the one who actually says 1. Well, it goes back and forth between 1.3 and 1.4. It's the 5 voltage port which measures the Ethernet port. The line below is the one which goes back and forth between 1.3 and 1.2, actually shows the FPGA circuitry. Now, in 5 seconds, the packet generator will send another burst of packets. Well, basically it's sending 8 million of packets at 140 bytes, this time at 1 gigabit per second. The packet generator right now is going to send 3 million packets of 140 bytes in each of the 4 ports of our router at a bit rate of 200 megabit per second. We can notice in the GUI of our router that the packets start arriving. Here on the left we have the packets received per second in all the 4 ports, and in this column we have the packets who are going to be sent back to the packet generator. And we can see here, if we focus on the first port, that at second 75, so about 20 seconds, it took about 20 seconds to send all these packets. If we go now back to the oscilloscope, we see here the power consumption of our router, and we can see here the current power consumption of 2 lines. The 5 voltage line is the one on top, which is currently 1.39, and the yellow, which is 1.2, it goes back between 1.2 and 1.3, which is anyway the one related to the 3.3 voltage, which is the one associated to the FPGA circuitry. Now we are going to shoot traffic at a higher bit rate, exactly, and here you can notice that the power consumption went higher just because the bit rate that we have used right now is 1 gigabit per second per port. So we right now we're sending packets at this bit rate, and here the frequency went to 125 megahertz. In a little now, exactly now, we just finished sending these packets because all the packets have been received, and the power consumption goes back to the one of the 62.5 megahertz. And if we go back in the GUI, we can see here the new packets here. These 2 red lines correspond to the second time that we shoot packets, that we sent packets, and it was higher number of packets at a higher bit rates. Here again is the port where we have received the packets, and here basically same graph, because we are forwarding all these packets back to the packet generator.